Thanks for attending this lecture. Yvette started introducing my co-authors. There's actually going to be talk about multiple projects here. Chris Jones' work will be prominently featured, and so will Dan Kammen's work, who wears many, many hats. One of them is he's co-director of the Berkeley Institute of the Environment. And then there's Eric Massonet, who has worked with me for a number of years and will on a new project that I'm going to announce in a couple of minutes. I think you've all heard about the Berkeley Institute of the Environment, which is sort of an umbrella organization for a lot of things environmental at Berkeley. But I think it's worth reminding that we have had a dedicated center for green engineering, design, and manufacturing at Berkeley since 1993. In fact, I think we're one of the oldest such organizations. I'm very proud to be the director of this. We have a number of faculty and students from all over campus working on 3 strategic areas. The civil infrastructure systems area, basically summarizing all of the infrastructure that we have an interest in, the electronics industry, and then servicizing products. And I'm going to touch upon a lot of these today. So most of my talk is about carbon footprint research and give you a sense of what it might be and what the role of the consumer is. A lot of the work in environmental assessment has focused on industries, on the producers. Now we're starting work, and not just us here at Berkeley, but at many parts of the world, by focusing on the consumer and consumer behavior and consumer actions. So I'm going to summarize how we're contributing to environmental assessment research at Berkeley. I'll show you some detailed life cycle inventories that we have undertaken and we're undertaking. Then I'm going to show you the LEAPS model, which is Chris Jones's work, and then tell you about an upcoming project for California Air Resources Board that is a follow-up to these other ones, and then tell you a little bit about the research challenges too. Interesting times we live in. We have AB 32, the Global Warming Solutions Act, which is one of the world leader acts, I would say, and a lot of the world is actually looking at what California is doing through AB 32. The goals are here to return to greenhouse gas emissions to 1990 levels by 2020, and in the process boost annual gross state product by about $60 billion and create 17,000 jobs. It's a lofty goal. The problem with this, if there is a problem, is we're struggling with how this will be implemented, and we're struggling with figuring out what steps and what policies will have to be taken. The goals get higher and higher. By 2050, we're supposed to drop 80% below 1990 levels. So that's the challenge and the motivation for this work. A lot of people, pretty much everybody out there, is asking, what is my carbon footprint? How I'm going to comply with AB 32, and if I'm not a California player or a California industry or a California consumer anywhere around the world, this is coming down the pike. How will I comply to the AB 32 in our area? We are the 7th largest. It's not what it shows on this graph because it's a little outdated, but we are the 7th largest economy in the world. So a lot of people are looking at us, but some of the things we might want to implement are complicated because of our position. There are opportunities as well as challenges for being so large. One of the challenges, or actually 2 of the challenges, is that our consumption is continuously increasing for a lot of things, not all, in California. So how to maintain, if that's one of the goals, increasing consumption while still complying with AB 32 and the other AB 32-like acts that are coming down the pike. We're also increasing population. We're already about 10% of the U.S. This is going to just grow. And so everybody wants to find out their carbon footprint, and I'm going to give you the soundbite for this first part of the talk. Nobody knows how to do it very well. The numbers that you come across are not necessarily numbers that have been vetted, not numbers that have been audited. And so pretty much you open a newspaper every day, whether here in the U.S. or anywhere in the world, and you're going to see headlines like this. Walking to the shops damages planet more than going by car. And of course, it catches the attention of people, and then you start looking at the background, you start looking at the numbers, and everything is in the assumptions. Everything is in the models, the boundaries of the models that you use in the data sources. So pretty much different sets of people can come up with different conclusions looking at the same thing. just a couple of days after this came out in the Times from the UK, there was an op-ed piece in the New York Times about food that travels well. And the idea here was that the article mentions a study that actually looked at whether food coming from a longer distance is better in terms of greenhouse gas emissions than food that's locally grown and locally distributed. And the finding was that in the case of beef for the UK, that beef that's actually exported from a long distance from New Zealand has a lower carbon footprint than the beef that's produced in the UK. And again, you can dispute the studies, but these are the kinds of numbers that are being promoted out there. Just another headline, CO2 output from shipping, twice as much as airlines. The two cannot really be compared. And so again, you got to look at what's in the denominator. What are these numbers being normalized by to come up with the right answer? The beauty of this field is these days that it's really boiling. A lot of things are happening. Again, everybody wants to get these numbers done. The challenge is that the community isn't expending a whole lot. If we look at this campus, the story is not very different. I think we need to hire in this area. I think we need to entice people to do more projects in this area, because otherwise we're going to see headlines like this. And this is what the general public sees. So we have a mission here. There is demand for carbon neutral products if we're worried about carbon. Willingness to pay to solve global warming. This was a survey of US customers. A large fraction of them are obviously not necessarily willing to pay a whole lot, but most people are willing to pay something. And there is a significant fraction that's willing to pay a lot, and these are US dollars per month. So there's clearly some demand out there for these services, and there's willingness to pay. What's the role of the customer? It's not a new phenomenon. Maybe the numbers that are coming around are new, but about 80% of the annual greenhouse gas footprint of an average consumer is attributable to the purchase, use, and disposal of retail products. So retailers are coming around to be interested in these things. The Walmarts of the world, the Tesco's of the world, the large retail organizations want to know what their footprint is so that they can educate their customers and then they can label their products appropriately or take some other action to go down the path of sustainability. The problem is that right now the consumer is guessing at best what's right. And often our gut feelings, even without comprehensive and life cycle numbers, are good. An SUV versus a compact car, there's not a whole lot of discussion about what's in the denominator. Incandescent versus compact fluorescent bulbs are a little more complicated, but there's literature on it, and the public hears about those numbers. But how about paper versus plastic cups? One of my favorite examples ever. We still don't know to the greatest extent what are those numbers. What are those numbers in California, in the US, in Japan, or around the world? Some of these fundamental studies for the fundamental questions are still missing, or paper versus plastic bags. The problem is that rather than the customer, it is somebody else. It's an invisible hand often that's picking the right answer for the consumer. And I'm going to talk about this green electricity in a couple of minutes. This is what we spend annually as a household, and this is what we spend on housing, transportation, food, goods, and many services. Keep in mind that this is the US, not necessarily representative for the rest of the world, and keep in mind this is a snapshot in time. If you looked at the trends of these annual expenditures, some of these categories have been increasing very substantially and increasing the problem of people like us who worry about the numbers. That is that there's a lot of growth in this one column. We are a service economy. We are becoming increasingly a service economy. And if you look at the literature, this is where we see the least numbers, whether that be carbon footprint or any other environmental impact. We know quite little about what the environmental footprint of things in this service column. We don't have perfect numbers for housing. On this campus, we do research on lifecycle assessment of buildings in the School of Architecture, in engineering, and elsewhere up at Lawrence Berkeley Lab. But I don't think anybody has the ultimate numbers yet. And so this is a challenge. The challenge is to fight these kinds of headlines that we see. There's progress. In January, I gave a presentation here about sustainability research and where it has come from and approximately where it is today. So today I'd like to report on some of the, filling some of the white space of making progress. What we need to do, again, the soundbite out of this presentation is life cycle assessment. We need to take into account everything that goes on with a product or a service throughout its life, from the initial stages when materials and energy are procured for the product or the service, through manufacturing or construction, the use phase, and then some kind of an end-of-life fate. This is, I think, clear to everybody who is in this field, yet we often consciously leave out some of these stages because we know better, because some of these we know are not going to matter. The matter of the fact is you don't know what's going to matter until you have done the work and look back and say, maybe next time I don't need to spend so much time. But unfortunately, we're not there yet. And I would like to send a message to all of you is not to forget that this is the boundary we ought to be operating in. Lots of inputs and lots of outputs we need to look at. These days, the issue is carbon. But environmental assessment worries about many other things, and sustainability is about many other things but energy and carbon emissions as a result. So again, just to keep in mind, life cycle assessment ought to have a very well-defined process that goes from the beginning point to the end point, yet often it isn't clear where the studies fall within this framework. We often don't spend a whole lot of time in defining the goal very well of the study. Who are we doing this for? What is the ultimate outcome? Who's the audience? How are we to present the numbers? Inventory analysis is mostly what you see. If it's not followed by impact assessment, it is not a very worthwhile exercise because it's hard to define who's going to use it for what. And again, I point back to these headlines. These are some sort of inventories with some sort of boundary, with some sort of data sets and models used. There is no consistent set of models or data. There's not a whole lot of auditing of the above going on. Therefore, we see these numbers appearing from different places. Let's just stick to carbon for a little while. This is the pie of various kinds of electricity generation sources in the U.S. About half of it comes from coal. And so one of the first places we ought to start this research is to look at this pie and say, do we know the carbon footprint? And of course, for things like carbon and natural gas, it isn't very complicated to calculate from a mass balance perspective. But if you look at, and I won't name either company names or anybody else, but if you look at what some people put forward, a lot of these categories are zero. Coal is a non-zero number. Natural gas is a non-zero carbon number. But nuclear may be zero. Hydroelectric may be zero. And this category may be zero. So investment into renewable sources often presumes that we eliminate the bad guys and there's free lunch in some of these other categories. There isn't. There isn't an energy source that is zero carbon and has never been. So an example of a work that's trying to fill some of this white space we did here a couple of years ago with a PhD student from the Energy and Resources group. And we found that of the choices given for a specific geographic area, which was the upper Colorado River Basin, and given the local conditions and the data sets that we had available, looking at almost all of the life cycle phases in great detail that we could get data for, we found that wind was the choice among these 5 options. Hydro was by no means a zero source of CO2 emissions. Photovoltaics were number 3, and of course coal and natural gas, as we know, have a lot of emissions. This paper came out 5 years ago. I still see a lot of spreadsheets that next to hydro have a zero CO2 emissions. Nuclear, notice, was not on here. I would love to do it if I can get people to cooperate and give us data. So the problems we're trying to address here is that consumers lack the understanding of the environmental footprints of their consumption, not just carbon, their options to mitigate these kinds of impacts, and we want to know what they are. Industry lacks appropriate signals from the various stakeholders, from the consumers and other industries to reduce their environmental impacts. I mentioned to you about life cycle assessment. One of the basic things we ought to look at the processes behind the products and the services. This is nothing new. Some of these processes are very well documented, others are not. And given that we're in a CITRIS forum, I'm going to mention that information technology is one of these areas that have very little information here. That is, that if you want to find out the carbon or any other environmental footprint of a minute of a cell phone call, that's a very hard number to come by. And the only reason I don't say that nobody has it because somebody might, they're just not publishing it. And that's where our consumption is going, towards more consumption of services, information technology and communications, towards more tourism, towards more leisurely activities, and other things that don't necessarily have a smokestack. And those are the areas that we have a problem with, even on this level, figuring out what the process is. Imagine we wanted to find out the carbon footprint of the internet. What would the process diagram look like? It'd be very complicated. So one of the things we need to keep in mind is that in the economy, nothing happens in an isolated fashion. Products interact with other products, producers interact with other producers, service generators interact with service generators. So we want to map out the supply chains behind producers of all kinds of products and services, and it's very complicated. One way to assure that that's done and look at it is really to consider that all of these problems are economy-wide problems. If you make a change somewhere in this matrix, which is, I won't get into too much detail, but the structure of any economy, whether that's local, regional, or national economy, anywhere in the world, there are inputs and there are outputs. There are sectors that produce inputs, there are sectors that use outputs. And by the way, this is how the GDP is calculated. So a good way to start is to start on this national or any other level economy view so that we don't miss a large part of the picture. Easier said than done, obviously, but again, I point back to this process-based look of the world, which isn't a whole lot easier either, and tedious, and expensive, and time-consuming. So in order to do this, about 10 years ago, we started looking at other fields in environmental assessment, comprehensive environmental assessment, whether we can learn from them in order to estimate this mapping, in order to have a view of who is in whose supplier and who is producing from what ingredients for which end users. And the consumer is also, by the way, in this framework in the form of final demand. Exports are in this framework because they are also part of our final demand, and imports are too. Imports are part of our economic structure. So we looked at general interdependency model. This is a work that was done or started at Carnegie Mellon about 10 years ago, or actually longer now, 12 years ago. We looked at general interdependency models that did exactly this or do exactly this to answer economic questions. What are the interrelationships among sectors and how are they quantified? The value of this for environmental assessment is that you can add emission factors to these bits and pieces of interrelationships. If you know how many dollars are purchased by one sector and how many dollars are sold to another sector, those dollars on an atomic level can be associated with an emission factor for those dollars of inputs or outputs. So this general interdependency model was extended to environmental analysis. Notice Leontiev got a Nobel Prize for it. This is the economics part in 1973. The economists no longer consider this a very snazzy model because the planned economy is not a very snazzy item to talk about these days, but the value for environmental assessment is clearly there. So one of the things that this would be able to tell us is for an average car what components on a dollar basis, as well as what components on an environmental basis are used up. And the beauty of a general interdependency model is that it really draws in everybody from a supply chain. In other words, we don't need to make judgment calls about where the boundaries are and who we are leaving out, which of the stages of a life cycle of a production we're leaving out and which we're including. So a lot of this haphazard decision making in the modeling stage is taken out. So I mentioned everybody's in the supply chain, so things like conferences, things like coming here and teleconferencing it to the world, things like research and development and planning, the kinds of services we often don't take into account when we are looking for a smokestack get accounted for. So the first set of studies that I'd like to focus on is actually the detailed studies. As I mentioned to you at the beginning, we have a lot of problems, and we have relatively few people out there. So it's really problems chasing people, and the pool of problems are growing every day. So one of the things we're doing is actually looking at some of the fundamental questions out there. And mind you, paper versus plastic cups we're not looking at, and trying to do a detailed study. It's, of course, not going to give us answer about the thousands and thousands of products and services that we consume, because it will take us a long time and a lot more human resources to do that. But again, we're tackling, and we have completed some of the studies about some of these major questions. We're just a short, maybe a month away from finishing our study on passenger transportation, so that we don't just look at the tailpipe emissions from a car or an SUV and try to compare it to a bus or an airplane, because it isn't a fair comparison. Somebody has to pay and carry the burden of environmental footprint of the infrastructure of all of these various kinds of transportation options, some of which don't share the same infrastructure. So we build a specific one for them. We have finished the work on freight transportation already that I'm going to show you in the next slide. We're working on green logistics, trying to optimize logistical networks, not just by time and money, which is the traditional way of looking at them, but also by the emissions from these logistics networks. We're looking at data centers as a particular subset of buildings, and we have a large effort in mechanical engineering on semiconductor manufacturing. Again, fundamental question. If you want to find out what the environmental footprint of a computer is, it's a good place to start to look at semiconductor manufacturing. So we have worked on office buildings before. We have worked on, and we're continuing work on water provision. How much electricity, how much energy is associated with providing water in California. This is a California-based study. Selection of plastics for the end-of-life options for computers, so that computers are in fact recyclable and not just throw away at the end of their lives. I already showed you the work on electricity generation, and we have worked on, and we are working on pavements. Again, a huge question out there, a multi-billion-dollar question every year. So this paper is coming out in Environmental Science and Technology just in a couple of days. Comparison of freight transportation options. There are not a whole lot of data out there that, same story as for passenger transportation, look beyond the tailpipe. We have actually done that. We have looked at the infrastructure as well as the production of the fuels. And if you look here, you're going to see that the fuel combustion part, or the tailpipe part, is indeed the most significant stage for things like carbon dioxide and nitrogen oxides, but it's not the most significant stage for things like particulate matter and carbon monoxide and SO2. In fact, the infrastructure, the white bars, contribute very significantly. So yes, there is more interest than just the carbon footprint, which would be more or less answered with these sets of bars. But even here, if we only looked at the tailpipe of the vehicles, we would be missing 10, 20, 30% of the picture. And so if we're trying to optimize by something, we need to do these fundamental studies first. The next stage in this is the realization, as I mentioned, that we won't be able to do these detailed studies for every product and every service in the economy. And so Chris Jones, who couldn't be here today, a staff researcher at the Berkeley Institute of the Environment, started this as part of his master's thesis to try to come up with a screening tool for the variety of things in that household consumption survey to be estimated. And so the approach is to actually find the carbon footprint for about 1,100 categories of goods, food, goods meaning industrial goods, food and services. Anything, it's a bit of an overstatement, but anything anyone can buy. Now, if you talk to Walmart, they're going to say, we wish we only had 1,100 products. We have more like 40,000, but it's a good start. The idea here is that we want to improve the consumer decision making. We want to make it transparent and, what's important, available to the consumer, not just the retailers, and promote carbon neutral shopping, if there is such a thing, at the point of sale, online, or with affiliate cards. In terms of production, producers need this just as much as the consumers do, because these studies just don't proliferate yet. Identifying emissions reductions opportunities in the supply chain. Their first action could be to not do it themselves, but push it down to the supply chain and ask everybody to carry their own weight in the analysis. And providing incentives for manufacturers to prove that their products are better than the average. So in fact, one of the goals of this LEAPS model is to come up with averages in these categories of retail goods and promote these averages to a point where manufacturers will want to improve upon them so that they are not just at the average. If they're above that, one of the first things they want to do is just be at the average. But some forward-looking ones will definitely want to go beyond that. An early version of the LEAPS model is already on the net at carbonneutral.org. If you go there, you're going to see an application that would help put a carbon number on the common household things we consume to estimate or give a first estimate of the total climate or carbon footprint. And this site also allows or will allow to link to carbon offset providers so that somebody can take an action right away. I was told that an improved version of this will be launched early next year. So the LEAPS model is going to be based on this one, but the LEAPS model is going to use better data sets and sort of more detailed modeling. And here are the details of that. This is in collaboration with Carnegie Mellon's Green Design Institute, which is the source of most of the greenhouse gas and economic data. So the units of analysis will be greenhouse gases per dollar, as well as greenhouse gases per unit of a product, which would be, in the case of products, the weight in grams, for example. And in terms of the various stages, the life cycle emissions would come from all of the supply chains up to the production stage, the transportation to the market, and then the impacts of the final retailer. So as far as comparing it to the existing climate footprint calculator, this might also have country or U.S. state specific data, which would modify the greenhouse gas intensity based on the place of production. And the location of the retailer would also be taken into account, and the energy mix that they are using may modify this greenhouse gas intensity, as well as the distance to market. This is sort of the food travels question of where is beef coming from New Zealand better than locally produced beef. The transportation options need to be taken into account. I won't bore you with all the details, but we start out in the LEAPS model from a Department of Commerce definition of the major categories that we spend dollars on, consumer dollars on, and we end up down here. Actually, in LEAPS, we are going to end up here, but the ultimate goal is to go one more level down, so beyond the 1,100 products, which in some fashion are averages of the data we start out with, and do an even better job Identify, I mentioned this is a screening tool, the products and services that will most likely, at least on the average, have the highest, the largest carbon footprint, and then do a more detailed study on them. I started out by saying we're already doing some of that, but I'm sure there are going to be surprises in this category that we will want to study further on later. Here are some preliminary results. Actually, I'm going to cut to this one right away. This is where the major categories of products and services, as well as some specific products, fall. X-axis, grams of carbon dioxide equivalent per dollar. Y-axis, grams of carbon equivalent per gram of product. So, by and large, the major categories fall in this sort of first quadrant of the graph, about 500 grams of CO2 per dollar. As far as the weight of the product, of course, there's a bigger spread, which indicates that dollar isn't necessarily the best unit to normalize by. We might have some products that have a high carbon content per gram, but are not necessarily very expensive. And then looking at some of the specific items, and this confirms some other people's finding, is that some of the highly carbon-intensive products in our consumption are great candidates for further reduction, such as meat in general, such as cheese products and milk products in general. And there are certain things that we don't necessarily start with, or we won't worry before we took care of these. These results have not yet been published. We have a paper under review, but there are clearly some surprises here. So if we look at, in summary, at the total greenhouse gas emissions of a typical U.S. household using, I believe, 2005 data, we can see that transportation and housing are the ones that dominate, not surprisingly at all, our total footprint. Food is next, goods and services. So I mentioned, and that's a bit of good news, I mentioned that there is a lot of growth in the service area. It does not appear to be the most important thing of the categories that we currently spend dollars on, but it's certainly something to be reckoned with, because if you look at here, the green bar represents the indirect emissions from a dollar spent, and almost all the dollars spent in the service sector don't actually increase the footprint of the sector where we're spending the dollar. It increases the footprint of somebody else. And so when looking at a smokestack, we don't necessarily find one here. The smokestack is someplace else. What would happen if we wanted to have a reduction in this household climate impact by 50%? We would actually need to reduce the transportation and the housing impacts by about 2/3. So we're putting this out as a thing to ponder over if we're going to want to pass public policy, or if we want to meet our own state's greenhouse gas goals. There'll be very radical steps that will have to be taken. It will not be easy. It will not be painless. If we wanted to reduce our footprint by 80%, which is the goal of our state by 2050, we will need a very substantial reduction in everything we do. 90% reduction in transportation impacts and 90% reduction in housing impacts. How much will this cost? There are all kinds of numbers out there. There is the Stern report from the UK. There's an IPCC report. We find that about 1% of total U.S. consumption, which is about $6 trillion, so in total about $60 billion, will be enough to offset these emissions. And there could be a lot of discussion, and I won't want to go into that, whether those offsets will work just as well in their first year as in their 100th year. But this is a straight economic calculation, which is about 30% of IPCC's own estimate of $200 billion per year that would have to be spent to stabilize greenhouse gas emissions. And finally, I want to tell you about a third project we're going to start on January 1st that will bring what I just said to an even more detailed level. We're starting a project with the California Air Resources Board with the ultimate goal of creating, or at least informing, labels and standards for the state. So we're looking at opportunities to reduce California's, so a specific life cycle assessment study, greenhouse gas emissions through the life cycle of retail products and services. And this is between Lawrence Berkeley Lab, Eric Massenet, and Carnegie Mellon. What we're going to do is first develop a California-specific LCA model so that we move away from the averages that some people have and our own LEAPS tool or a climate footprint calculator uses, and really find out what it is and how it is that California consumers spend their money, what are the expenditures, are they different from the national average, and how do producers of products and generators of services behave. We will only be able to do this, given the time and money, for 20 to 30 products, which is a far cry from the number of products that Walmart is selling, but that's what we can do. We will estimate the lowest achievable life cycle greenhouse gas emissions by product or service, and we will play scenarios to see what is the technical potential for some of these products as far as greenhouse gas emissions go. So pointing back here, this is a wish list, and we may not currently have the technology, and we may not currently have the stocks of products and services to even achieve these kinds of reductions. So we will only be able to do this initially for 20 to 30 products. In terms of developing this LCA model for the state, we will have to start with a production phase energy analysis. It will be based on input-output analysis, which I mentioned earlier. In the use phase, we're going to look at the California stocks of certain products, typical operating energy use data, and energy mix in our state. And at the disposal phase, look at both recycling and waste disposal options so that this is truly a life cycle inventory. As far as the California EIO model, and I hope in 2.5 years I can stand here and be proud of this work, we are going to include the interstate and international commerce, because a lot of our goods are sourced from a different state or from overseas, China, for example. So we will not stop at the boundaries of our state, but we will actually extend it to wherever the production happens. There was a recent study published a couple of months ago that showed that that's a significant chunk of the pie to look at. Scott Matthews, with his PhD student, and he's part of our team, found that the U.S. produced about 22% of the CO2 equivalents of the world in 2005, but U.S. consumption actually accounted for about 25 or 26%. So some 4%, 3 to 4% of our greenhouse gas footprint actually is elsewhere, not in this country. So we'd like to find out what that number is for California. We will use local, to the extent possible, energy and environmental data, and we will build on 2 case studies out of a preliminary model that we developed in 2005 on semiconductors and pharmaceuticals. Let's see. In the interest of time, I'm not going to talk about this. Let me just talk a little bit about the scenario analysis part of this technical potential. We're going to look out only 5 years, realizing that technologies are going to change more significantly outside of a 5-year period. We will be specific to these 20 or 30 retail products, and we will look at sort of naturally occurring reductions based on things like stock turnover. If you buy a more energy efficient computer, that is going to show up in these stock numbers. And we will look at current energy efficiency and possibly some technical efficiency that we know of to look for these greenhouse gas reduction trends. And we will recommend low carbon product standards, which might become mandatory, and we will recommend a way to put a low-carbon product label on goods, which, at least in the beginning, will probably just be voluntary. So just to end with one example of how this might look like, last year for the UC Energy Institute, we completed a study where we looked at the stocks of computers in California, both desktop PCs and notebook PCs, and estimated the life cycle greenhouse gas emissions from owning and running these computers from the production, use, and end-of-life stage, both inside California and outside California. This is both in terms of the production as well as all the other stages, and found that about 5 million megagrams of CO2 equivalents are associated with our current PC stock. This is equivalent to about 1 million cars driven average distances in the state, or about 1% of our net greenhouse gas emissions. So then we looked at the reduction potential too. What are the kinds of things that are being talked about, and what is there in percentage terms a production or a reduction potential in the various stages of the life? Things like improving the manufacturing energy efficiency, reducing the emissions from the semiconductor manufacturing, which again I mentioned there is great work being done here on campus by Dave Dornfeld and his students. In the use phase, we look at things like power management, better and more radical power management, or purchasing nothing but Energy Star compliant computers, turning off the PC during periods of non-use, and extending the life of the PC or maximizing recycling at the end of the life. And we found that that number can be reduced by about 28%. And note, there's not a whole lot of technological innovation in these reduction potentials. I'm going to skip this and just show you that the potential for one product, this is just one product in California, is a reduction of about 11 million tons of CO2 equivalent emissions over a period of, 7 years or so, 8 years. So we would like to do similar things for these 20 or 30 retail products and see what is the potential. And I'm sure we're going to find a lot of low-hanging fruits as far as the carbon footprint goes. Lots of challenges. I've mentioned them on the way here. Large number of questions, not enough people to do them. Large number of products to look at if our focus is the consumer. We want to look at the most significant problems. Therefore, a screening tool like LEAPS or the Lifecycle Climate Footprint Calculator is very useful. There's lots of uncertainty in the modeling and data, so we need to find a way to deal with this. We anticipate design changes. So even if we come up with the most perfect numbers, they may be obsolete very quickly because the supply chains are changing dynamically. The designs of these products are changing dynamically. The functional unit of products are changing very dynamically. Just think about your cell phone. 10 years ago, it was truly a phone. Today, it is some product that's called a phone, but has many, many other functions. And we want to find a way to keep these numbers updated over time. So in conclusion, there is clearly a willingness to pay for climate change. And 9 years ago when I came to this university, I think that the issue was very different. I think there were lots of enthusiasts. I think there were lots of questions. But if you ask the general public, they would not necessarily want to dole out the money. I think times have changed. Models to measure the environmental footprint are being developed. I think we're far from days when everybody will agree how to do things and how to interpret the numbers. I think the incentives are there by both the manufacturers and the retailers to become climate neutral, but we're lacking implementation. So we will need to spend a lot of effort in effective public and private partnerships so that companies come forward and work with us. We need to offer carbon offsets. Efficiency will only go so far, extremely important, but there will be always a large percentage of products and services that will not be able to be further reduced. And we need to invest in this LCA method and, if you will, technology so that indeed these numbers get updated regularly and that they are scientifically defensible, a lot of which are not today. So thank you very much for your attention.
Park. Do we have any questions?
Hi, I'm not sure if this is within your purview, but when looking at the carbon footprint of the household,
Okay.
you just pass the slide. Do you have an idea if a household or a person might, which sector a household might be more willing to reduce?
We don't. Sorry.
Thank you.
I have a quick question.
Yeah.
In the typical LEAPS analysis, it seems like it appears as if you stop at the point of purchase, and I was wondering if you include the use and end of life analysis. I mean, you did in the last example, but is that sort of typical in the in life cycle
They need
analysis?
to be. Yeah, they need to be included. And so the numbers you see here are inclusive of the use phase. They're not inclusive of the end of life. So whether your product ends up in a landfill or ends up recycled is actually, if it ends up recycled, it reflects these numbers because recycling may save some resources. So the generation of the next product may have a lower footprint to start with. But the end of life is the one that's the least worked out in the numbers you see here. But the use phase is included.
This is kind of related to that question, but earlier this year there was a sort of a debate on campus with the CEO of Whole Foods and the food writer Michael Pollan about, they were talking about similar things, and one of John Mackey, the Whole Foods CEO's assertion was that it's okay for Whole Foods to fly in asparagus from Argentina because the amount of energy that you actually spend to prepare your food makes all the other energy costs insignificant by comparison. So it's related to that last question. In food in particular, it seems like the kind of food and how you prepare it can actually have a pretty big impact on that. I'm wondering if that's taken into account.
Absolutely. I've not seen numbers, but I believe it. But the question is really not either or, but both. You gotta look at both. In order to have a meaningful reduction, there could be no sacred cows, right? No pun intended, but organic food. So I think you got to look for opportunities. If it's the way you prepare the food, it's certainly reflected in these numbers, in the household energy use numbers. But the manufacturers will have to do things about it because there's only so much we as consumers can do, right? You can eat your food raw, or you can cook it, right? But where do you go from raw, right? So I think everybody really will need to carry their weight. And the problem is that there are these assertions. I haven't seen the numbers, right? I could add to that by saying, retailers, by the same token, should be the ones to start because they're the ones that keep our food from spoiling.
I have several comments. The input-output analysis is an excellent source of determining the quality of the input into it, and therefore should you question those, but also then allows you to prioritize the studies that you will do. The other part of it is you show transportation as being the major thing here, and yet other people say it's only 25% of our CO2 problem. And perhaps then we should challenge also the efficiencies. The automobiles and steam generators are around 40%. What happens to the other 60%? Can we use that, as I think we do on this campus, low quality steam for other uses in heating and uses that way? Can you expand that to the general economy? On the political side, why do us old farts get the benefit of living in great big carbon footprint houses for no economic advantage other than we pay lower taxes?
Bunch of questions in there. Let me just comment on one. I won't comment on the size of the house you live in. That 25% that you see for transportation is not the right number. The same way that the 40% you see for buildings is not the right number. The 25% is the tailpipe emission from transportation. Does it include the oil refineries? Does it include the construction of the roads? Does it include the construction of the service stations, et cetera, et cetera? And the answer is no, it does not. So I think that's why you see partly a disconnect between sort of a macro look of where our emissions come from and more a micro look, a bottom up. Some of those numbers will need to be reevaluated. Laura.
How would your models incorporate changes in consumer behavior, such as one announced in the Chronicle this morning that said that California has consumed 0.6% less gasoline this year than last year, and that was flabbergasting because of the increase in population? And maybe because of people's interest in global warming reduction, there might be more change in consumer behavior?
Sure. The question is, where do you take the cross-section, right, in these data? And we take it, or so far have took it on an annual basis, right? To the extent that there are local variations within a year, they will just show up in the average, right? The beauty of the model is that you can plug that you can already do that at carbonneutral.org. There are some average numbers that you can look at. If you disagree with them on your level or on a broader level, just change them. Decrease, in this very case, your gasoline consumption by 0.6% and see what happens. So I think the best answer to this is we want to create a model that people can log in and play scenarios with on a personal level as well as on a higher level.
So your answer to my specific question is you said how does your updated model based on annual figures?
Well, the expenditures are annual.
Yeah, so if you do it on a change in the driving pattern, then that would show up in the aggregate numbers you're using per year.
Sure. But that's what we have scenario analysis, right? Yeah. See what happens if this changes, if that changes. Yeah. You can do the same and you could make the same argument for environmental data, too, is that there may be a major technological change. How do we handle that? Well, we modify the emission factor.
Okay, we have one more. So just a quick question. You had mentioned that you were doing some work on data center analysis and the energy use in data centers.
Yeah.
And I was curious if you had looked at all, or maybe to suggest to you looking at comparing these sort of distributed computing projects, such as these folding at home, SETI at home, et cetera type projects, to the traditional centralized supercomputing facility. Have you had any numbers on that yet, or if you were even looking at that?
No. I think it's a good idea. The distributed nature of things is being discussed for many other things, like distributed electricity generation and water treatment. And I think you have a good point. We probably have many more millions of data centers that way than we have centralized. I don't know who has the data. We're just happy to do it for the centralized data centers for now.
Another question?
Yeah, quick one.
So last question.
I was surprised to hear that you were able to do all of the carbon offsets with just 1% of the product pricing. Could you tell me how that was done, and if that really offsets the entire carbon or just brings it down to 1990 levels?
Well, what we did was we looked at how much we spend on food, goods, and services and other categories, and we assumed that we know what the emissions are, right? That's this graph, and we assume that the emissions will be offset at $10 a ton of CO2, which is a standard. You could buy carbon offsets at the Chicago Climate Exchange or from private vendors at about that price. Some are lower, some are higher. So turns out if you add all of these up, it would add only about 1% to our total U.S. consumption. which is about $60 billion. That's how we did it. Not too much.
So what happens to those offset dollars that we could buy?
That's a different presentation. I don't know. Okay. Thank you very much.
Thanks.
Thank you.
Thanks for our